and along with Andrew Hessel, we have written a new book called The Genesis Machine, which is about a new field of science that combines engineering, design, and computers with biology. These techniques allow us to engineer living cells. And 10 years from now, we're going to talk about synthetic biology, this new area of science, as having changed everything. There are three reasons that make this book particularly relevant right now. The first has to do with investment. SARS-CoV-2, which is the virus that causes COVID-19, acted as a catalyst for genetic sequencing, for synthesis. In effect, it broke us free of our existing mental models for what a virus was and how it spread, for pathogen detection, new ways to inoculate people. And that attracted significant investment. Some biotech veterans recently just raised $3 billion to create a new company on the premise that the fundamental machinery of living cells can be reprogrammed. There's a flood of capital being directed at synthetic biology right now, which means that in the next 24 to, let's say, 36 months, we're going to start to see this ecosystem really develop. This is going to have some important knock-on effects on different industries, pharmaceuticals, obviously, and also healthcare. But we're also going to start seeing changes in agriculture, industrial materials, even space, because we've now proven out that it's possible to reprogram the fundamental units of life. And that's going to catalyze innovation. And it's really important as more of this investment comes in and more of these technologies are developed, that we too break our mental models for how we think about life and how life could evolve. So that's the first reason. The second reason has to do with risks. And there's a lot of them. In the book, we identify 9 risks, and they aren't insignificant. And I just want to highlight a few because I think they're really important. In the future, the most worrying data security breaches could actually involve our DNA. And this means that, biology, this biological era that we're entering, it could be a major information security problem. There are easy ways to scrape somebody's genetic code that could have widespread implications if that person is a politician or if that person is the CEO of a big company. Biocybersecurity is another important emerging problem on a much grander level. And then another important risk is, we think that synthetic biology, because it promises so much, could actually lead to new geopolitical conflicts. We think the next war could be a biological one. And we're going to have to prepare for what's coming. And I'm not necessarily talking about biological weapons, but rather consolidating power and resources. The third reason why it's important right now to be thinking about all of this, and the reason that we wrote the book, actually has to do with solutions. It's hard to get people to change. And we just saw at COP26, the big climate change conference, that world leaders are just not going to act fast enough to mitigate the climate crisis, especially when what we're asking countries to do is to stop contributing to their economy through scaling back some of their manufacturing or having to change it. We're going to have to develop alternatives. And in this case, synthetic biology gives us optionality. There are other ways, in addition to reducing CO2, through regulation, there's other ways to potentially solve this problem. There are also other ways for us to grow our food. So the reason that we wrote the book now is because we still have a little bit of time to sort through these questions. We've got ethical questions. We definitely have risks. There's a lot of money flowing into this space. And ultimately, we're going to have to make personal choices going forward. And we should do that when we're informed, not under duress. In my case, I was interested in health for a variety of different reasons, but one of those reasons had to do with a string of miscarriages that I had had. And it just seemed strange to me that in this age of artificial intelligence, birth and getting pregnant was really left up to happenstance and hope. And anyway, so I got really interested in this. I started doing additional research. I heard Andrew's name. He's a microbiologist. Turns out we had a friend in common who introduced us. And together we sort of realized that we could take this book that I already had in progress on synthetic biology, but make a much deeper exploration of it and unlock some of our perspectives and research for a much wider community. So in this book, we created 5 scenarios as a way of helping make all of this research and all of this information much more real to people so that they could really envision what the future could look like so that it related back to them. So these scenarios, which are written a little bit like speculative fiction, are in fact rooted in research and models and data and science. The first scenario has to do with a fertility center set in the future. We started with a prompt. How could synthetic biology influence how we create children in the future? And some of the questions we had included things like, if you could select the genes for your offspring, what would you select? What would you not select? And why, right? What would the reasons for that be? And if you selected a few things, could that create an imbalance in another place? What would that process even look like? What would an actual trip to a futuristic fertility center be like? So this first scenario is intended to give you a very visceral understanding of how this technology could be applied to completely change how we think of who is a parent and what does the construct of a family look like. I'm a big Chicago Cubs fan. They won the 2016 World Series with David Ross, who's a catcher who was born around the same time that I was, and whose knees should absolutely not have been working during the series. Anyhow, all of this got me thinking. As much as I would love for that 2016 World Series winning Chicago Cubs team to play forever, what would it be like if they actually could play for a very long period of time? So that's kind of where we started. But that got us thinking through, if people are able to live much longer, much healthier lives, how does that change the future of work? How does that change the relationship between a CEO and an executive team, or a CEO and a board of directors? How does that start to shape what a board of directors might be doing? If you're a family company, how does that shift the decisions that you make? What does succession planning look like in a world in which people can live much longer than they do today? And then we even started thinking through, sort of the legal frameworks and the laws and governing the Supreme Court. What would happen if we had a Supreme Court justice who was on the bench for 60 years? So we wanted to explore what that world might look like, but more importantly, what the implications would be and the type of planning that we would need to have for the younger generations that would be coming up behind those elderly Chicago Cubs players. The third scenario of the book is a where to eat guide. I'm sure, regardless of where in the world you live, somebody is probably publishing an annual list of the best restaurants. And since synthetic biology will influence how and where we get our food, whether that's meat produced from cells versus plants, but in a bioreactor rather than on a farm, or someday we might get the freshest sushi that you've ever had in your life from a bioreactor in Nebraska versus off the coastal waters of Nagoya in Japan. We wanted to explore what that future could look like. So we wrote a restaurant guide set in the year 2037. It's actually based on Adam Platt, who's a writer for New York Magazine and a restaurant reviewer. We were imagining him in the future and what he would be reviewing. So if you're a foodie, that is a chapter that you will either love or you will absolutely hate. Andrew's really fascinated with community and how people relate to each other and how science changes our expectations of each other. He also, as I, think that we've been approaching our climate change situation without an open mind, and that there's probably other ways to think through this. So starting with a prompt that has a lot to do with Elon Musk. So if you are interested at all in what Elon Musk has been doing in Austin, Texas, that's where our story begins. And we explore groups of people who, in an effort to figure out what it would be like to live off planet, wind up moving underground. And it's a really interesting alternative viewpoint into ways that we might mitigate climate change and live differently. The fifth scenario is my favorite, although it's really scary. Maybe that is why it's my favorite. The reason that it's so scary is because it's absolutely plausible. We found a paper written by a couple of academics who were curious to know what happened between having genetic code in one space, one academic lab somewhere, and sending it off to China, which is where oftentimes the sequences are put together and sort of sent back. So that's a very normal thing to do. There's a couple places in the world that do that. Well, what happens, if you send computer code back and forth, there are always vulnerabilities and possibilities for somebody to inject malware. What if somebody injected malware into genetic code, but it was undetected? And so these academics figured out that could happen. You could come up with new code, edited code in the lab, send it off to get it printed. And there are protocols, security protocols all along the way. But there's also a couple of loopholes they found. And so on the way back, it's possible that the totally innocuous code that academics might have sent out could come back as a pathogen, completely unbeknownst to them. So that was where we started. What if something like that actually happened? What would be the response? So this scenario starts with that exact situation having happened. There's been a catastrophe in a lab. A lot of people have died, and people aren't sure what to do about it. That last scenario is written as an FBI memo, and it traces the steps that we took to figure out who's actually in charge of that type of situation. And the answer, I'm not going to give it away, but the answer is not a good one. I recognize that synthetic biology is a new term to just about everybody. And at some point, artificial intelligence was also a new term. We talk about artificial intelligence today, but most of what we're talking about has to do with other things, like the impact of automation. AI is here. It's invisible. Most of our daily activities require it. It just kind of is. It's fundamental. I think we're going to be in the same place a decade, 15 years from now with synthetic biology. At some point, people will become aware of that term, and then it will stop using it because it just is. It's just part of life. So I guess the thing I want to stress is this is a book about science, but this is not a science book. This is a business book. And it's also a book about, society and the future. I recognize that some of what's here is going to be too radical for a general audience, and potentially too radical for CEOs, and too radical even for an audience of scientists. Because what we're really asking is, what happens when we remove our current evolutionary constraints? What happens when we explicitly view biology as a technology platform? I think the biggest and the most durable inventions of the 21st century are going to be at the nexus of biology and technology. And for that reason, I cannot think of an industry that synthetic biology will not have some impact on over the next decade. So pharmaceuticals, industrial materials, the auto manufacturers, banks, everybody in some way will play a role in what's coming. For a while, there were a lot of CEOs making decisions that had to do with the futures of AI, but they didn't have the right understanding or knowledge. And as a result of that, at some point, there was a ton of funding, and then a lot of that funding dried up in the 80s when AI didn't produce what everybody thought it was. So part of what we're trying to do here is level set. We want the business community to actively pay attention to what's happening, but we also want to temper expectations. The challenge is that our best possible future is not going to just show up for us fully formed. That future is going to be a result of the decisions that we make in the present. There are things that we can do, right? We have a misinformation problem. Less than half of the planet has received a vaccine for COVID, and that's a result, in some cases, of limited supply, but it's absolutely the cause of misinformation in many other places around the world. And if we can't get our heads straight about a vaccine, and if we're allowing so many crazy other stories to enter our thought space, it's going to make what's coming much, much more challenging to wrap our heads around. The genetic databases, for very good reasons, don't tend to include people of color. And the reasons have to do with mistrust. Historically, our governments have done awful things to people of color in the name of experimentation. Horrible. So we're going to have to figure out ways to engender trust, because on the other side of this, again, is optionality. Some of what this technology does gives us optionality. It also gives us other ways to think through the problems that we keep trying to attack with similar solutions that aren't making any real change. There's an experiment to rewild the woolly mammoth. And I know it sounds like crazy Jurassic Park stuff. But the real reason for trying to resurrect the woolly mammoth isn't because it sounds like a cool science experiment or somebody's really got a hankering for woolly mammoth steak. The reason is because if we can rewild the North with animals that used to, with their weight, push down onto the permafrost and allow grass to grow, and they were part of that ecosystem in a way that helps us to mitigate some of the CO2 issues and some of the warming issues that we're having. My point is, what gives me hope is that between human ingenuity and the science and technology that we have access to, we can right some of our wrongs and we can create better futures. But we can't approach that with outright fear or a complete utopian ideal. We have to take a pragmatic approach. And if we can do that, then yeah, I think we live longer, better, healthier, happier lives. I really do. It's going to be hard work, though.